Tonight is February the 11th, 2025, and this is the stereo version of the little amplifier I named Little Jewel SET 807s. It's just a double version of this schematic right here that's posted. It's everything in here is component correct, except there's two channels instead of just one, of course. Even the power supply is the same. I did change these capacitors right here. I'll show you what I did underneath. Really pretty simple. The only thing that's not exactly the same is this feedback resistor. I put a little bit more negative feedback in this amplifier, but everything else is the same. 100K, 0.1, 470K, 150 ohm resistor, 75K, etc. It's the same. Okay? Matter of fact, this schematic right here, if you look across the internet, you'll find pretty much this schematic. I think it's becoming the most common one out there, with some slight variations. Some people don't want to use any negative feedback. I believe in a little bit of negative feedback. NFB is our friend, as I had someone tell me one time. Also, a lot of people, if you don't use negative feedback, you don't use this right here, you can put a capacitor out there and get a little bit more gain. And you can put a capacitor here and get a little bit more gain. Well, I don't need any more gain. As a matter of fact, when you leave these resistors off, you get a little bit of local feedback. This is NFB, global NFB, GNFB, global negative feedback, all the way from the output of the transformer back to the first stage. That stabilizes the amplifier. Without some feedback, the power response and the frequency response is just all over the place. I mean, it's kind of like having, here's my analogy of it, it's kind of like having a car without any shock absorbers on it. And when you go over a bump, it just oscillates until it finally, runs out of energy and stabilizes. You've got to have a little bit of negative feedback, in my opinion. And besides that, it improves the power output and the flat frequency response of it dramatically. Just a little bit. Like 3 to 6 dB in these SE amplifiers. In a vacuum tube amplifier, 16 dB is pretty common. You get too much more than 16 dB in a push-pull amplifier, and it's likely to start motorboating at low frequencies. Even if you can't hear it, sometimes you can see the speaker just very slowly, very slowly oscillating at about 1 hertz. Anyway, enough of that. I'm really pleased with this thing. I've become an SE guy. It's hard for me to explain, but I prefer the sound of this to all of the high-end Macintosh stuff and everything else. Okay, well anyway, let me quit babbling here quite so much. Here's the front of it. I'm at the side of the input. I didn't get too fancy. Let me turn on the light. I get so much darn glare here. Nothing real fancy. I just labeled them left and right gain. I did use the nice Switchcraft RCA connectors. They're actually a good idea. I'll show you something here. I'll show you something. These guys right here, which are really fancy, and I like them, but they break. I don't know. I think when you put this thing through the hole, I'm trying to get it to focus. It's trying to focus on everything else. When you put this thing through the hole, and if you tighten this nut too tight right here, it just breaks off. It breaks right there. This part and this part separate the threaded part. Or if you put in a lateral force on the outside, it can just snap off. So as much as I like these are a lot better. They cost a lot more too. These are pretty cheap. These are like $2 a piece. But anyway, to each their own there. These are some knobs off of, I think they go You know, years ago I did a little bit of repair after retiring for a guitar amplifier. I think these are common. These are the knobs are like Fender or Marshall amplifiers. I'm not sure. But anyway, they work. Left gain, right gain. Okay, in the back I did a similar thing. When I walk up to something, I like left to be on the left and right to be on the right. Left, right. So I did the rear the same way. Already got everything plugged in. I mean, it's pretty simple. I always promote the EIA type of connector, because when you unplug it, you don't have to, you know, move your amplifier around with this power cord hanging out, so you're tripping over it and everything else. I got a 2 amp slow blow power switch, which you may or may not. I always like a power switch. You may or may not need it if you plug it into some controller. And then left and right. It's all 8 ohms. There's only one output on these transformers. They're 8 ohms. I think they're 6,000 ohm primary to 8 ohm secondary. The only thing that's a little bit different, that ended up slightly different, is the way it's laid out on the top. And the way it's laid out on the top, this is the right channel and this is the left channel. So everything is left and right until we look at it this way, and then this is right and left. And if I had to do it all over again, I would probably put the two 6S and 7s right here. I'll show you the symmetry underneath it in a minute and you'll see kind of what I mean. And I'd put the 807s over here. They're pretty hot there too. I'm using a 5U4 in it right now, an old one too. Boy, isn't that a pretty one? You know, they made some really good stuff back in the 50s and 60s, and if you look at the getters on these, they look like they just came out of the factory. I also want to show you the performance of some new tubes in it. These are good. I actually am a real fan of Tungsol. I'm not trying to convince anybody to buy them or buy anything else, or that one is actually better than the other, but I personally have really good luck if you buy new tubes. Now, I've got plenty of 6S and 7s. Let me show you right here. This is my 6S and 7 stash. I think there's about 20 tubes in each bag here. So I guess I've got 60 or 70 of them. And there's some more over there. When I first started this project, I thought about using the 7N7. Can you see those guys right there, those lockable base ones? But I've only got 3, and I said, now that'd be insane, wouldn't it? But I've got 50, 60 of these to play with, and I've only got 3 of those. That means I'd have to go into getting some more to have a stash to play with. Well, I'm glad I stuck with the 6S and 7s. The 7N7, those loctile base tubes, let me get it out here. This is it's got the same characteristics as a 6S and 7, but it's a loctile base. And also the physical layout of the pins is such that it lends itself very nicely to symmetrical feeding of the plates to the next stage. Anyway, so that's what that is. Let's see. We're going to do a little bit of testing. Let me show you underneath it. Turn this thing over. It's turned on, and I'm going to leave it turned on. Just keep my fingers out of the bottom of it. There's what it looks like underneath. Let me see. Where's my non-conductive pointer? I really don't want to stick my finger. There it is. Here's the power supply down here. You know, I said I changed these capacitors right here. These I used 150, 450, but this one has a little bit higher voltage in it because of that transformer. So these are 100 microfarads in series. So I got 50 and 50. But I got them right. But you know, when you put them in series like that with a balancing resistor across it down, I can put as high as 900 volts on it. So they should last a long time. Choke. Here's that 3K resistor. This guy right here, and I only needed one. The voltage amplifier part draws so little current that one resistor worked. I thought I might need two, but I didn't. You know, one works just fine. Here's the capacitor on the output, and these are the two cathode resistors for the 807s. Now you got to look at these. Look at these pretty little resistors right here. These things are just really nice. These are some really fancy ones I found. I've probably had for decades. Look at that IRC BW. I got two of those in there. That goes from the plate to the screen. That's how you get the screen voltage. I wish it would stay focused, but sometimes it doesn't want to. If I back off a little bit, there you go. There's one there, and then there's the other one up there. On the input right here, these 0.1s, they are Bumblebee. I test them very, very thoroughly. I even put the full voltage on. They're rated at 400 volts. Read that 0.1, blah, blah, blah. There's the yellow band right there, says it's 400 volt. And I put 400 volts on it from this guy right here. I can crank it up to whatever I want and put 400 volts across and let it stay there for some time, you know, ever how long I want it, to make sure they're good. And not only that, but even if they did leak a little bit, it really wouldn't matter up here. It wouldn't matter. It wouldn't matter right here in this part of the circuit if they did. And these types of capacitors are sold on the internet, on eBay, as tone capacitors that people put inside their guitars, where the voltage level is in the microvolt level or millivolt level at the most, you know. And they like the sound of those capacitors. I was so, and still am, so charmed by the little single channel SET amplifier that I wanted to make sure I used vintage capacitors in it, which I did. Here are these Cornell Doublier, or however you say that. These are the 0.25s, as you can see. They're all labeled very nicely. There's really not too much to talk about here. What I talked about symmetry is from this gain control goes straight into the tube right here, right straight into the grid. This one had to go to a terminal strip and then a little piece of shielded wire over to this one. That's why I say I would actually probably put the two 6S and 7s right there if I did it again. These are some ceramic standoffs right here for the high voltage for the plate connection, and the feedback resistors are right here. They're 1K instead of 10K. On-off switch. I don't know. You know, there's not too much to talk about. I mean, that's pretty much the whole shebang. We'll do a little bit of testing here. Let's back off. Okay, let me lay this, lay it back down. I'm being very careful not to get my fingers underneath it in any way. Here on my little turntable here. Okay, there it is. Now let's get over to the test equipment. Let's move this guy right there. Move around as little as I can. Look at let's put a signal in. We put it into the right channel. Yep, let's crank it up here. There we go. Got to get rid of some of this glare. Let's see, does that help? Well, sort of. Oh, that helped a lot, didn't it? Oh yeah, now we can actually see what's going on. Well, as usual, I want you to be able to see as much as possible all at the same time. But let's start out with just these two right here. Sine wave output and power. That's 0.77 watts. If we run this thing up to about 3.5 watts, and we're running it at 2 kilohertz, you can see there, and its THD is 0.85. You see that? There's its THD. There's its frequency. And I think, and there's its power in watts, 3.47. There's its pretty sine wave. Now, I think I've commented on just about all of my videos that I use two, so that I don't have to be twisting the frequency knob. That way I can just punch the buttons and I can go from 2 kilohertz to 200 hertz, or to 20 kilohertz, or to even 20 hertz. If you know what I'm saying. Now, here's what's absolutely amazing about it. I got to scope in on this guy right here. Look at the harmonic profile of it. That's it. I'm lost for words. It's so clean. For an SE amplifier? That's 10 dB. See, the big pulse on the left is to 2 kilohertz, and each major division there is 10 dB, so it's 10, 20, 30, 40, 50 dB. The second harmonic is like 55 dB down, third harmonic is 50 dB, the rest of them are like 55 or so dB down. There's just, wow. Now, we can get our harmonic profile, we can get our SE harmonic profile by raising the power a little bit. I'm cranking it up now. There it is. Well, yeah, I forget it. It scans kind of slow. That's a little more typical of an SE amplifier, but it actually is doing amazingly well. But that's up to 8% distortion, and that's at 4.6 watts. Here, I'll tell you what I'm going to do. I want to back off here now that you've seen that. You might have to kind of squint to see everything at once, but maybe that's the best thing to do right there. That way you get to see everything at the same time. We're at 3 watts. So here's what we're going to be watching. Let's see, clear right. Oh, there's our harmonic profile. Well, why did we not see that a while ago? I don't know. I must have been doing something wrong. Well, anyway, there's our sine wave. There's our power in watts, 3 watts, 2 kilohertz right over there. There's the, I wonder why I didn't see that. I must have had it at a much lower power. I thought I had it at 3.5 watts. I'm going to run this thing back up to 3.5 watts. I don't know, maybe I had a loose connection, because that looks normal. That is the harmonic, that is the signature of the harmonic profile for an SE amplifier. You got all of them. Now here's something that's kind of interesting. I have selected, intentionally and on purpose, what I consider to be the very best tubes out of those 60 or 70 that I have over there to keep the second harmonic as low as possible. You see that right there? See, third, fourth, it's on a pretty classic SE amplifier, the second harmonic is here, the third harmonic's a little lower, fourth, fifth, it's almost a straight line across. But this one has a lower second harmonic. Now I'm going to show you something. I'm going to replace that tube with a different one. It only takes a second. And I dare say, this, I had to turn it off. I got to pull that guy out. Let's see, left and right channel. Okay, see, it's going to go away. Okay, we got to let the tube warm up, but it'll come up pretty quick. You'll see it come up pretty quick when you see the sine wave come back on. Okay, now watch how this tube changed things. We'll just let it scan itself. Well, that one didn't change very much, did it? I tell you, it's a pitch when you do something so many times that you want to show it and then it won't do it right. There you go. See how the second harmonic came back up? See, now it's about as big as the rest of them. I think it comes up a little bit higher here in a second. It warms up a little bit more. Now, would that sound different? Would you hear that? You might. Second harmonic, pretty strong, pretty, very nearby. So would this tube right here sound different from the one that was in it? Okay. Now let's put in a new tube. I'm going to put in one of these guys right here. These are new tubes. Okay, very nice. I really like them. See here? These are the nice Russian successors of Tungsal. Okay, I got to turn it off. Watch this. Okay, let's see. That's the right channel, which is this one right here. Put that in there. And turn it back on. Gotta let it warm up. I can't speed that up. This thing right here is always trying to save itself. I wish it would just stay on. Let's look at watch the harmonic profile of this one. Yeah, these are new manufactured tubes. Okay, look at there. See the second? There you go. Now that's pretty classic right there. See how the second is bigger than the third bigger than the fourth, second, third, fourth, fifth. That is the classic SE amplifier profile. I don't think you can see that very well. Darn. That's really important. That right there. And that's with the new Tungsal tubes. I may have to do some of this over again. I don't know if you can see that very well. I am going to do it over again. In my opinion, that would be the classic SE amplifier harmonic profile sound. We love it. Okay? Yeah, I should have been a little zoomed in a while ago. I fumble a lot, huh? Okay, watch this. Let's do this again. Okay, turn it off. And I'm going to put in what I consider the highest quality tube, because it's going to give us the lowest amount of distortion. Not significantly, but just a tiny bit. And watch what this one looks like. There you go. Now, see there? Look, the second harmonic here is lower, right? I'm going to turn out some more lights so you can see just how fantastic that is. Now, from an engineering standpoint, that would be better. What do you guys think? But from a sound standpoint, from an SE amplifier sound standpoint, I'm not sure it'd be better. I mean, am I documenting by coincidence the sound of a tube? Yeah, I mean, if we're changing the second harmonic, I think we're changing the sound of it, regardless of the music we're playing or regardless of the speakers it's being played into. Okay, since I didn't do a good job a while ago with it, I'm going to put the other tube back in. Okay? Okay. I'm going to put this new Tungsal back in there. Okay. Patience. We're getting there. Okay. Fundamental second, third, fourth, fifth, sixth, seventh. Okay, watch the second harmonic come back up this time. There you go. Classic. I like it. Can't fight that, can we? It's reality of whether we like it or not, or whether we understand it or not. Okay, I'm going to have to stop this thing and regroup here for a second. I'm going to zoom out. By the way, this is at 3.5 watts. 3.5 watts right there. And in particular, this one right here is at 1.5% THD, which is completely okay. And there's this beautiful sine wave. So let's stop for just a minute. Be right back. Okay, what we're going to do here is I'm going to have to tell you where I'm measuring it, but I'm going to be touching the probe. This is an extremely accurate meter. It measures, as you can see up here, the AC and the DC component at the same time. Okay, this is just for documentation, and I know a lot of you want to see this kind of stuff. Each side of the high voltage transformer going into the rectifier is this right here, 380 volts. That's 380 volts each side of the center tap. So if you double that, it would be, what would that be, 760 volts center tapped. That's what that is. Okay? Now, the DC voltage at the output of the rectifier is 420 volts. There's no AC component in it either, and there shouldn't be, of course. If we look at the output of that 3K 10 watt resistor that's feeding the 6SN7, it is 376 volts or so. Okay? Okay, on the plate of the first stage of the 6SN7, the voltage is 51.2, whatever. That's on pin 2. Pin 3, which is the cathode, which is the first input stage, it's 0.56 volts. Half a volt. Okay, on the next stage, the plate is, let's see, it's grid plate, cathode, grid plate. The next stage, the second stage of the 6SN7, the plate voltage is 245. The cathode is, this is the one that has the bypass capacitor on the 22K in the bypass capacitor. It's 58.9. And that's really about all you need to see. Well, no, it's not either. The cathode of the 807 is, that's its bias voltage, by the way, 31 volts. And that's across a 500 ohm resistor. You can do the math there. I equals E over R. Divide 31 by 500 and you'll get its current, which is going to be about 60 milliamps. The screen voltage and the plate voltage are the same. Here's the screen right here. That's where that 100 ohm resistor touches the screen. And the plate itself, going directly to the plate, is the same. So there's no drop across that 100 ohm resistor. That's really it. You can't measure the voltage directly on the grid of the tube to ground, although I'll show you something here. Well, let me show you something. If you want to measure the grid, the actual grid, you can kind of do it. You can get something pretty close. You can't get exactly because you'll load it a little bit. If we want to know the voltage right here on this grid, we have to measure it from here to the cathode. The bias voltage is from the control grid to the cathode, not to control grid to ground. But the current available here at the grid is basically zero. It's probably in the microamps, if not nanoamps. So when we put even a 10 megohm meter across it, we will load it down. But I'm going to measure from the grid to the cathode directly. Grid to the cathode, okay. There's the cathode. And here's the, let's see, we got to go back up here. You got to be able to see this. Grid to the cathode. This is direct reading grid to cathode. Measures 30.67. That's its actual bias voltage, but it's loaded ever so slightly. And if you'll notice, this voltage is slightly lower than the cathode to ground voltage, because the ground measures this. See there? This is where you measure it accurately, because when you try to measure it directly from grid to cathode, you load it, and it's going to be slightly lower because your meter, even though it's 10 megohms, is going to load it down ever so slightly. So there is that, what that is worth. Hope that's worth something to you. I find all this stuff pretty interesting. Kind of stuff we were taught way back when, you know. And it's kind of nice to measure it and play with it. Well, I don't know really anything else to tell you about it. Well, I'm going to stop here and think. There might be something to lengthen it just a little bit more, make it a little longer. Hopefully not too boring. Be right back. Okay, we're starting out here. What I'm showing you right now is the purity of the square wave that we're putting into it. I don't want to start tweaking it and showing you, because it's really, really touchy. A square wave has the fundamental, which is the first one, and only the odd harmonics. And this is a 2 kilohertz square wave. If it was not completely symmetrical, I can show you by turning the knob, and then I got to tweak it for another 5 minutes to get it exactly right again. You'd actually have another little pulse in between each one, a little tiny pulse in between each one, depending on how much out of symmetry it is. So we have a beautiful symmetrical square wave with a rise time in like a nanosecond. So there you go. Okay, now what we're going to do is I'm going to take the output of that off. I'm going to put the amplifier back on, and then I'm going to put that perfect square wave into the amplifier, and here's what we get. This is square wave response. I'll show you the oscilloscope here in a minute. See, it generates a little bit of the even harmonics there. See those little ones in the middle? Those are even. Because the perfect square wave, as you just saw, was just the fundamental and all the odd harmonics. And that's at 1.4 watts of a square wave. So it is creating its own little harmonics, which is okay. I mean, that's what it does. And then now that we are really satisfied with that, man, that is textbook beautiful. This is its square wave. Let's see if I can. It's about as close. It's got a little bit of wiggle in it, but you know what? I'm not going to worry about it. I think what we have to do sometimes when we have something like an SE amplifier is take a deep breath when it comes to the so-called engineering part of it, because I think we can engineer the sound out of it. If we make it look like a laboratory grade, you know, pure like the amplifier at the front end of an oscilloscope or a spectrum analyzer, which you do want to be absolutely pure. If we make it sound like that, then we come to the conclusion that it sounds sterile. Well, that's its 2 kilohertz square wave. Now, to make the coners square, I mention this pretty much every time, to make the coners nice and square on the square wave right here, the leading edge, to make it nice and square, the amplifier has to be able to produce at least up to the 10th harmonic. or it'll end up being rounded. Pretty square. It's got a little bit of overshoot, the tiniest amount of wiggle, but it's just absolutely insignificant in my opinion. I can't believe it turns out this good. Okay, let's turn the lights back on. And let's zoom back out. And there we go. I'm trying to think, is there anything else we really ought to examine about it? Well, I'll just make some points here, and I won't belabor it too much. I thought about deciding, I'll take the camera off here and I'll show you. Well, I don't really have to go too far with this, but like say, what size fuse in the AC line should you use? And what I've always been taught, I don't think you can really see it there, but I use these little things, and it says it's running at I think about 150 volt amps. Well, if you divide that's its apparent power. It's also known as reactive power. It's not exactly watts, but it's close enough for what we're trying to determine here. So it's drawing about 1 amp is what it's doing. 1 amp times 120 volts would be 120 volt amps. So it's a little bit more than 1 amp. And I've always been taught to double that for a fuse. So put in a 2 amp, probably a 3 amp. Or a 2 amp slow blow, maybe a 3 amp slow blow. You know, don't put in a 10 amp. I've made the mistake before of building high power stuff where I got a 30 amp primary fuse, and then I've got smaller things on it like filaments and small power supplies that I forgot to add in secondary fuses, and I've had them go bad and then burn up because I can't blow that 30 amp fuse, if that makes sense. Okay, well, I can't really think of anything else too exciting about this. Oh yeah, no, there is actually one more thing I got to show you. Let me get set up here. Okay, we're set up again. I've got my vintage 6SM7s back in there. I got my engineering mentality ones in there, and if you notice down here on the harmonic profile, it's got the lower second harmonic instead of the other one where the second harmonic is higher, running the little tongue saw tubes, which perform extremely well. You'll see, you know what I'm talking about right there, is that second harmonic. If we put the tongue saw tubes in there, it comes up a little bit higher than the third anyway. So what we're doing right now, this is probably the last thing I think you might be interested in. We're running at 3.5 watts. 2 kilohertz. Let's see. I took that loose a while ago to measure something. Let's put that back on. And there's our 2 kilohertz. 3.5 watts, 0.9% THD. Now all I'm going to do here is, I'm going to go right over here and show you what I'm going to do. I'm going to just pull the 5U4. You can pull it out with it powered on. It's okay. Don't ever pull your tubes out with the power on, but you can pull your rectifier. It doesn't matter. And then I'm going to put in a solid state and watch what happens. Solid state. Boom. Power didn't change. Let's see if our harmonic profile changes. No. It actually went down a little bit. And look what our THD went to. It went from about 0.9, see that number right there, to 0.37, 0.38. Nothing, I don't want to turn it over and start getting into too many more measurements. Just take my word for it. It changed the plate voltage about 50 volts. Our harmonics went down dramatically by raising the plate voltage about 50 volts. Just raising the overall power supply voltage. Nice, beautiful sine waves. Stayed right at 3.5 watts. And our THD dropped pretty dramatically. Now I believe, here I'm going to run it up to 1%. Watch this. I think we get about 4.5 watts out of it now. I like the 1% mark. That's just... There you go. There's 1%. And there's our power right there, 4.75 watts. By going, sorry, I gotta move it around here. I know that sometimes you guys complain it makes you dizzy me moving it around, but I gotta do what I gotta do just by putting in a solid state rectifier. Boop. But you know what? And you get a little bit higher voltage if you use a 5V4 rather than a 5U4 and all that kind of stuff. So you can drive yourself crazy. Would we be able to hear that? Well, I don't know. Maybe you guys can tell me. Well, that is it. I can't think of anything else. I'm going to move it back into the living room. I'm not going to make a video of any music tonight. I'll see if I can get some help in drawing up a schematic for it, a component correct schematic. I've actually drawn it up in LT Spice, but that's not the best way to do it because I can't just freehand draw things. So we'll see about getting a schematic to it. But the schematic of the single channel amplifier is correct, except in this case. Well, I do use slightly different output transformers that I get from my friend in Poland. I think that has a lot to do with it. I think they're magnificent transformers, SE transformers. But the single channel schematic is correct. And your voltages will vary slightly depending on what power transformer you use. You know, you don't have to have anything round to the exact volt. We just sometimes got to live with what we can get. Well, thanks for watching, ladies and gentlemen. Stay safe.